Cybersecurity is not new to any of us, but sometimes you experience something that really opens your eyes. Last winter, my son and I went to a layman's hacking course organized by the Danish Society of Engineers. It was, of course, conducted in a protected environment, in a lab, but it was fascinating and a bit unsettling to see how just how vulnerable we can be and how easy it is to intrude controllers, computers, and networks if not properly protected. The internet is full of programs to help you and ideas on how to do it. This experience made me realize how crucial it is for all of us to pay attention to cybersecurity, especially as threats continue to grow and evolve also in industrial environments. I'm really looking forward to sharing some important insights about cybersecurity, specifically in the context of industrial controllers and networks. I'm Lars Pasgaard. As a product manager for controls at Johnson Controls in Denmark, I understand the importance of cybersecurity and paying attention to this in industrial controllers. A key responsibility for me at Johnson Controls is the depicted Unisa 4 controller, which was launched earlier this year. Today, I will talk you through what implications the cybersecurity threat landscape have for industrial controllers. Using our new Unisa 4 as example, I will explain how we have addressed cybersecurity in the development project and when in operations at customer applications. I will also go a little into detail about what we have done to make Unisa 4 cyber secure and what we are doing to help customers staying protected. Let's have a look at the evolving security threat landscape, why we should care, and some consequences if not paying due attention. The list of points I brought as examples. There will be many more if you start scrutinizing the threat landscape. Cyber attacks are on the rise, also posing serious threats to industrial systems. Attackers are employing advanced techniques that challenge traditional detection and defense mechanisms. Industrial controllers are integral to critical infrastructure, making them prime targets. Companies are facing heightened regulatory demands for robust security measures. Human errors remain a significant vulnerability, so ongoing training is essential. The interconnectivity of devices increases potential attack vectors, necessitating comprehensive security measures. For risk and consequences, if we do nothing, we can say that protecting physical and digital assets from cyber threats is essential to prevent data breaches and financial losses. Ensuring security prevents disruptions and protects employee and public safety. Uninterrupted operations are crucial for success as cyber attacks can severely impact revenue and productivity. A strong security posture protects the company's reputation as breaches can damage customer trust and business relationships. Adhering to regulatory requirements boosts security and prevents penalties, while non-compliance can raise insurance premiums. Strong cybersecurity fosters innovation and trust, while weak security can hinder growth and reduce competitive advantage. Companies that experience breaches may become repeat victims if vulnerabilities are not addressed, leading to ongoing security challenges and cost. Understanding these aspects underscores the critical importance of cybersecurity in our industry. And why do we at Johnson Controls care? Here you see our Sabro products. For our chillers and heat pumps, we are using Sabro reciprocating and screw compressor units. For all these units, the Unisa 4 controller is vital to secure operation and to protect customer investments. And UNISAP 4 is our standard offering for this equipment. We care because our equipment serves virtually all market verticals, also critical infrastructure, and because safeguarding our customers against cyber threats is paramount for us. We are dedicated to ensuring our products meet and surpass the high security standards, providing both peace of mind and robust protection. Ensuring the cybersecurity of industrial controllers presents a complex array of challenges, just like making a jigsaw puzzle. Many controllers operate in environments where updates are difficult due to the critical machinery they manage, which cannot afford downtime, and they may be installed in places difficult to reach for updates. This creates a conflict between maintaining operations and enhancing security. Additionally, controllers within extensive local networks face numerous devices and protocols, heightening vulnerability risks and complicating the identification of outdated systems. Legacy systems, often not designed with modern security in mind, can be particularly susceptible for cyber threats. Furthermore, operators may lack the training needed to spot vulnerabilities or may hesitate to update systems for fear of disrupting production. To navigate these challenges, organizations must adopt a nuanced approach that prioritizes both security and operational needs. This includes implementing strong risk management strategies, exploring offline update options, and promoting cyber awareness among employees. A proactive and adaptable security framework is essential for safeguarding industrial controllers in today's complex landscape. In summary, we face limited connectivity, operational downtime, network complexity, legacy systems vulnerabilities, human factors that affect security awareness, and the ongoing need for a balanced strategy. To effectively address cybersecurity challenges, we have applied DevOps methodologies specifically to the development and operations lifecycle of the UNISAP 4. By incorporating DevOps security practices from the outset and fostering team collaboration, we streamline updates, enhance system resilience, and align security with operational needs. This proactive approach not only tackles vulnerabilities, but also creates a culture of continuous improvement among our developers. Excuse me. The Johnson Controls Global Product Security Team, GPS, plays a critical role in safeguarding our products and reducing cybersecurity risks. They helped us ensuring that the UNISAP 4 is built on a strong security foundation in line with the secure development and life cycle standards under IEC 62443. GPS also guide our customers in adopting security capabilities, making sure that security is integral to our offerings and empowering our personnel to meet high security standards. Implementing DevOps has strengthened governance in our development project by clarifying roles and responsibilities, fostering accountability and transparency. Continuous integration and deployment practices enable regular feedback, allowing us to quickly identify and resolve issues. This agile approach accelerates development while ensuring compliance with regulatory requirements, as security measures are seamlessly integrated throughout the lifecycle. By leveraging DevOps and a comprehensive security framework, we ensure that our UNISAP 4 controller meets and exceeds industry standards. In summary, our dedicated approach to integrating DevOps into the UNISAP 4 development enhances collaboration, automation, and security, ensuring high safety and reliability standards, while still adhering to established security principles. Achieving cybersecurity is complex and rests on multiple tiers, just like for modern cars. There will probably be other ways to understand cybersecurity, but a common way among software developers is to look at it as 3 tiers. The first tier is security for data at rest. This is protection of information stored and not actively being used right now, like files saved on your computer or when using a car allegory. The passive safety, that's my view, the passive safety in cars, like for instance steel beams in doors, crumble zones or wheel tires. The second tier is security for data in transit. This is protection of information that is actively being sent from one place to another, like when you send a message or stream a video. Linked to cars, this can be the dynamic safeties, like for instance adaptive cruise control or anti-spin systems. The third tier is for security for data in use. This is protection of information that is actively being processed or changed, either by other computers or by user interaction. In cars, it could be if you want to disable a critical safety feature via the display, like for instance disabling the anti-spin system. Physical protection is protection requiring special tools to gain access to physical risk touchpoints, like for instance USB ports and communications interfaces. This could be compared with a car key, for instance. Retaining protection is a targeted movement. So this is about keeping firmware updated, just like that new tires are key to safety in cars when the old wears out. Further hardening of industrial networks may be done by customers on their initiative, just like we can buy add-on features, for instance like a rear camera when buying a new car. This multi-tier security approach creates a robust defense against potential threats. In the next 2 slides, we'll further explore security for data at rest and runtime in the UNISA 4, as well as secure connections with adjacent systems. For security of data at rest in UNISA 4 controller, we have developed a layered approach where key measures include encrypted firmware, preventing unauthorized access and interpretation of our software, and ensuring only authorized users can access it. Digitally assigned firmware, allowing the UNISA to verify that the firmware originates from us, preventing installation of counterfeit software. The UNISA 4 employs secure boot technology to detect malicious changes to the firmware, while with a backup system firmware system for redundancy in case of compromise. These measures ensure our controllers are secure and reliable, protecting customer data and operations. Let's explore how we protect against malicious use and ensure runtime security in UNISA 4. For use protection, we encrypt user passwords, allowing operators to create accounts on the user interface with robust encryption methods like hashing and salting. These technologies are commonly used for securing user accounts and are also, for instance, used by social media. As depicted in the upper right corner, we use a combination of well-known system software and IoT technologies. On top of this, we use TLS encryption internally in the UNISA to protect data during internal transmission, ensuring secure communication between components. For communication with adjacent systems connected to the UNISA, we also use TLS encryption. A little footnote though, commonly used legacy protocols like Modbus TCP lacks encryption. However, we are prepared for an anticipated shift towards encrypted alternatives like Modbus TLS, but this also necessitates a corresponding architectural evolution in adjacent systems. To add additional runtime security, we require owners of Unisapps to fill out a whitelist on the screen. This whitelist is a list of computers on the same network as the Unisap 4 that are allowed to communicate with this or these. With these measures, we ensure that the Unisap 4 remains secure when interfacing with other systems, safeguarding customer data and operations. To keep our customers protected, we provide regular firmware updates for Unisap 4 through our extensive partner network. These updates are essential for maintaining security and functionality. Key aspects of our firmware updates include patching of vulnerabilities to address identified security weaknesses to thwart potential exploits. Renewing security certificates to keeping them up to date for secure communications, incorporating the latest advancements to enhance performance and security. And finally, adding new functionalities and improvements to ensure our products remain cutting edge. These updates are integral to our cybersecurity policy as discussed earlier. By regularly updating firmware, we empower our customers to maintain a robust security posture against emerging threats. In case customers want to secure the industrial controller network, we have compiled a comprehensive cybersecurity hardening guide for their convenience. So, as a wrap-up, with Unisap 4, customers get a robust security framework, advanced access control, continuous monitoring and threat detection, rigorous testing and compliance, firmware updates throughout the life cycle. So what's left for me is to encourage you all to stop by at booth 240 in Hall 7 to see what we are showcasing and to meet me and my colleagues for a chat. And if you're interested in listening to other insights, I can also mention that I have other keynote speakers among my colleagues. In Hall 4A, booth 419, in a couple of minutes from now, my dear colleague Søren will speak about overcoming the obstacles to achieve temperatures above 100 degrees Celsius with hydrocarbon-based heat pumps. Tomorrow, Stefan will speak about future developments in refrigeration technology with heat in focus. And then Dimitri will speak about decarbonization of steam generation with absorption heat transformers. So that was it from my side. Thank you for your attention. Questions are welcome. Yeah.